Hi everyone, this is Dr. Swaminathan Yasyam. Now I am going to discuss about the case study on VLSI design for the month of August 2023. The topic of case study is Intel processors. So first, the outline of today's topic is scaling from the 4004, that is 1970s, to current processor Core i7. So the courtesy everything is collected from the Intel Museum. So first, the Intel processors found on 1971, that is 4004. So it is from the Busicom calculator. The characteristics means that is 10 nanometer process or 10 meter process, 2300 transistors used for the frequency 400 to 800 kilohertz, and the watt size is 4 bit, and a DIP package, dual in package, that is 16 pin. So marks, that is cut from the Rubli. It is drawn from the color pencil, one metal, poly or diagonal lines. So based on the VLSI design parameters, the three main parameters are considered. First one, speed, that is processor and RAM. Next, area, that is how much it occupies, that is transistor size or gate size or integrated chip or integrated circuit size. Next, last one is the power. Power means we are using the milliamps, mAh, that is the 4004 transistor. So these three parameters are mainly considered for designing the Intel processors. Next we will discuss about the 8008, that is 8-bit follow on the process found on 1972. That is a thumb terminals characteristics, that is same for 10 meter process, and 3500 transistors are formed together to build 8008 transistors. The frequency range is 500 to 800 kilohertz, and the watt size is 8 bit and 18 pin, that is DIP package it is used. So 8 bit data paths are mainly considered, and individual transistors are visible. And next, 8080, that is another Intel processors. It used 16-bit address bus on the year of 1974 using the Altair computer, that is PC, and it is also using the 6 meter, that is from 10 meter to 6 meter it is reduced the process, because based on the nanometer technology only we are making the chip process. So transistor size, area, power, everything is decided based on the nanometer technology nowadays. So 8080 it found that is it is made based on the 4500 transistors and 2 megahertz and 8-bit watt size, and the pin means 40 pin DIP package. And next to the 8086 and 8088, it is a 16-bit processor and using IBM PC and PCXT. That is a revolutionary project which is found on the characteristics 3 meter, and 29,000 transistors are formed together, and 5 to 10 meter megahertz, that is 5 to 10 megahertz, and 16-bit watt size, 40 pins are roamed together, that is a DIP package, and micro rod ROM, read only memory. And next we will discuss on the 8086, that is 286 processor, that is another family. It is found on 1982, that is for virtual memory, and the IBM PC that makes the characteristics of 1.5 meter process, 134,000 transistors are formed, and 6 to 12 megahertz used, and watt size is 16 bit and 68 pin we are using for the regular data path and the ROMs. So bit slices clearly visible. So you can see the diagram. The bit slices, that is slicing diagram, is clearly visible because the route planning, that is a floor planning, and the placement and routing, these are all the important three concepts for building the processors. And next we will discuss on the 386. So it is a 32 processor which is found on 1985 for the modern into 86 characteristics. So it is found based on the 1.5 to 1 processor to 275,000 transistors are formed together to build 80386, and megahertz 16 to 33 megahertz it is used, and 32-bit word size which is created, and 100-pin PGA is used, 32-bit data path and ROM, that synthesis control is used. So this is the 80386. Next 80486. Here the pipelining concept is mainly used for the floating point unit, and also it is used the 8 kb cache for the characteristics 1 to 0.6 nanometer process, and used 1.2 mega transistor, that is 1.2 into 10 to the power 6 transistors are used, and the frequency range for the clock frequency range is 25 to 100, and the word size is 32-bit, and pin means 168. So here the extra additional features, we can use the cache memory, integer data path, FPU micro, and the synthesis control is used for the 80486. And next for the upcoming Pentium, it is used the superscalar process found on 1993. So 2 instruction per cycle it is run, and also for the separate 8 kb it is used for the characteristics 0.8 to 0.35 meter, and the transistors we are using 3.2 mega transistors, and the clock frequency range is 60 to 300 megahertz range, and 32-bit word size we are using, and also 296 pin used. The extra additional features are caches memory used, and data path processing, FPU control also used. And next the Pentium Pro 2 and 3, it is found between the year 1995 to 99, and the micro OPS cycle, that is out of order execution, and also it is used 16 to 32 kb, and for the multimedia instructions, and Pentium 3 adds, that is 256 plus kb for the characteristics 0.6 to 0.18 meter processor, and we are using the transistor sizes 5.5 mega to 28 mega transistors, 166 to 1000 megahertz. So the word size is the 32-bit, and extra additional features we are using the MCM and SEC cycles. And next the Pentium 4, it is found on 2001. Very clock frequency is very fast, like 256 to 1024 kb. The characteristics, that is 180 nanometer is just introduced, and based on the 180 to 65 nanometer it is used. So here the transistor sizing will be 42 to 125, and clocking frequency is 1.4 to 3.4, up to we can use 160 watts power, and also for the watt size is 32 to 64 bit. And next to the 478 pin we are using, and next we are using the unit starts to become the invisible on this scale. And next we are using the Pentium M. So Pentium 3 derivative, the battery power efficiency is 1 to 2 MB size. The characteristics means 130 to 90 nanometer, and next to the transistor size will be 140 into 10 to the power 6 transistors, and the clocking frequency is 0.9 to 2.3, and the power is 6 to 25, and watt size is 32-bit, and pin is 478. So here the cache, it dominates the chip area. So already I told the 3 parameters, speed, area, power is considered for designing the VLSI design parameters. Next, Core 2 Duo, we are using the Core 2 Duo for the dual core process 2006. The characteristics will be 65 to 45 nanometer process, and the transistor size will be 291 mega transistors, and the clocking frequency is 1.6 to 3, and the watt size will be 65. The watt size will be 32 or 64. The pin means 775, so it much better than performance and the power efficiency. Next, Core i7. Nowadays we are using maximum Core i7 for the Pentium style architecture. So it is used 2 MB size, that nanometer is 45 to 32 nanometer, and 731 mega transistor used, and the clock frequency is 2.66 to 3.33, up to 130 watts it is used. The size, watt size will be 32 or 64, and pin means 1366, and the multi-threading techniques used for on-die memory controller also used for a Quantum i7. And next, Atom Power, that is a low power CPU netbooks. It is used for Pentium style architecture for 512 kb. The characteristics will be same, 45 to 32 nanometer, and transistor size will be 47 mega, and 0.8 to 1.8 gigahertz frequency used for the power, 1.4 to 1.3, that is 1.4 to 13, and also for the watt size 32 or 64 bit. For the pins 441, the low voltage, so voltage size will be 0.7 to 1.1 voltage for the operation purpose. So it is an excellent performance. It gives excellent performance and power optimization. So this is the summary. So here we are using the 10 to the power increase the transistor count from 4004 to atom. So mainly it consider important parameters are year found, that is from 1971 to 2008, and also for the frequency size transistors and the clock frequency, word size, power range, cache memory, and package. So dip in package, dual in package also consider for the comparison between 4004 to atom. So as a summary, I said it is an important parameter for designing the VLSI design is 3: speed, area, power, and also based on the technology, nanometer technology. We can use the transistor size or transistor reordering, placement, routing, and also the floor planning. So these are all the important parameters for considering the VLSI design parameters for building the Intel processors. So my case study is the Intel processor. So now I am applying this concept into Intel processors, the comparison between 4004 to nowadays the i7 process and Atom. So the thing is, importantly, we consider the nanometer technology. It is going up to the March level. So here we are using the parameters, the nanometer technology, 3 nanometer. So nowadays we are using the 3 nanometer technology. Thank you.